Now let's have a go at a worded problem. Now, the idea behind most worded problems is they don't give you the diagram. So you have to read the question carefully and try and construct a triangle or construct a diagram that will help you solve it. So let's have a read through the question. The sides of a rectangular table are 150 centimeters and 360 centimeters. What is the length of the diagonal? Okay, so if you haven't already, pause the video and have a go. And then once you're done, let's go through the solution. So the first part of this is we have a rectangular table. So I would start off by drawing a rectangular table. So we have a rectangle. Now we've been told that one side is 150 centimeters. So let's write that as our shorter side, 150 centimeters. And 360 centimeters is the length of our other side. So 360 centimeters. Now the question is, what is the length of our diagonal? So it might be a good idea to actually draw out a diagonal. Now we know that the properties of a rectangle mean that all the angles are going to be right angles. So now you can see that we actually have a right angle triangle. Can you spot it? If not, I will draw it up in red for you. You can see that this right here is going to be our right angle triangle. Now, if you're not comfortable solving it within the rectangle, I would recommend you just draw it out separately. And you can see it's a right angle triangle, 150 centimeters here and 360 centimeters. And we're trying to find the diagonal, the length. So you can just call that X. So basically, we're trying to figure out what this is. And so we just write down the Pythagorean statement as normal. So we would say that the hypotenuse is X because that's opposite the right angle. So X squared is equal to, now we say the short side squared. So first short side is 150 squared plus second short side squared is 360 squared. Now we evaluate that. So X squared is equal to, now 150 squared, if you enter into your calculator, should give you 22,500, and 360 squared, if you enter that into your calculator, should give you 129,600. Now, if we just go further, we can say that X squared is equal to, so just adding those two numbers together, 22500 plus 129,600, that is going to give us an answer of 152,100. And then we just square root like usual. So X is equal to the square root of 152,100. And entering that into your calculator, you get a nice answer of 390 centimeters. So we would say that the length of the diagonal is 390 centimeters. It is important that we make sure we include the unit centimeters. Some teachers are quite picky and they'll make you lose half a mark for not writing the correct units. Okay, so this is a harder example. So maybe try and just pause the video and have a go. And then once you're ready, unpause it and we can go through the solution. So here we have two unknowns and we have to find X in the following diagram. Now, as always, I would always start off by just writing the Pythagorean statement. So what is our hypotenuse in this example? So we can see the side that is opposite to the right angle is 2x. So we should say that 2x squared. Now it's really important that you write 2x in brackets squared, because 2x squared, if written like this, is going to be different. So it's not going to be the same as 2x all squared, because 2x all squared means 2x times 2x, which is going to give us 4x squared, whereas this is just 2x squared. So you can see this would actually be double the 2x squared. So we have 2x all squared is equal to, now we square the first short side, so that would be just x squared, and then we square the second short side, which is going to be 16 squared. So now it just becomes an algebra game. 2x all squared, we've already discussed, is equal to 4x squared. So we write 4x squared here is equal to x squared plus 16 squared. Now, if you remember, 16 squared, you can put in your calculator, is equal to 256. So now, how do we solve this equation? Well, the aim of the game is to make x the subject. So we probably want to move all of our x's to one side. Here we have 1x squared here, which would be better off if we just moved it to the left-hand side. So if we said it was 4x squared, this is a positive x squared. So if we move it over, it becomes minus x squared is equal to 256. Now, 4x squared minus x squared, that's just the same as collecting like terms, like 4 apples minus 1 apple, we have 3 apples left. So we have 3x squared is equal to 256. And then from that, we can say if 3 apples is equal to 256, or if 3x squared is equal to 256, then we would say that 1x squared is equal to 256 divided by 3. If you put that into your calculator, you're going to end up with some sort of decimal. In fact, it might be better to just leave it like 256 over 3, because if you were to write it into your calculator, you're going to end up with 85.333, like 3 reoccurring, and that's probably not the best idea. So now we just find x. So x is going to be equal to the square root of 256 over 3. Make sure you put the square root over everything. That's a common mistake I see students making. And then if you square root that answer, you're going to get 9.2376. Now, depending on what the question asks for, if they wanted the exact value of x, I would just leave the answer as square root of 256 over 3. You can actually simplify this third, but for the purposes of year 8 and 9, don't worry about it too much. And if they wanted x to, let's say, 1 decimal place, then I would just write x is equal to 9.2, and that would be my final answer there. So it really just depends on what the question wants. Now we move on to a second worded problem. So have a go at this and try constructing a diagram that reflects what the question is saying, and then unpause the video so that we can go through it. A rod 2.5 meters long is leaning against a wall. The bottom of the rod is 1.5 meters from the wall. How far up the wall does the rod reach? Okay, so with this particular question, what you want to do is draw a nice diagram. So let's just draw the wall. I'm not an artist, but in fact, it might be better to not draw a 3D diagram. So let's just call this our wall. Okay, so we're going to draw a 2D diagram, and this is the wall. So there we go. Now we also have the ground or the floor. So that would be our floor over here. And we have a rod. Okay, so let's draw the rod, and it's leaning against the wall. So some of it's on the floor, some of it is on the wall. In fact, it might be a good idea to just draw it in a different color. So let's say green. Now, what do we know about it? We know that the rod is 2.5 meters long. So we know that this is 2.5. Also, we know that this is perpendicular because a wall and a floor is nearly always perpendicular. There aren't many walls that are leaning like this against a floor. So let's continue. The bottom of the rod is 1.5 meters from the wall. So what that is saying is that this distance is going to be 1.5 meters. So now the question is asking for how far up the wall does the rod reach? So really what we're trying to find is this distance here. How far up the wall does the rod reach? So you can see we have the hypotenuse. 2.5 is our hypotenuse. We have 1.5, which means that's one of our shorter sides. And we're just going to call this x because that's what we're trying to find out. So if we were to write the Pythagorean statement, it would be x squared plus 1.5 squared is equal to 2.5 squared. Now, if you enter all those numbers into your calculator, 2.5 squared is equal to 6.25. 1.5 squared is equal to 2.25. and we have x squared over here. To make x the subject, we first make x squared the subject. So we do 6.25 minus 2.25, and that is equal to 4. So if x squared is equal to 4, that means x is equal to the square root of 4, and that is going to be 2. So the answer would be the rod reaches 2 meters up the wall. Okay. Here's our third worded problem. A man starts from point A and walks 2 kilometers due north to a point B, then 5 kilometers due west to a point C. How far is C from A? Calculate your answer in kilometers correct to 2 decimal places. Okay, so pause the video if you haven't already and have a go. Make sure to draw a nice diagram. And now let's go through the question. So we're going to start off with point A. So let's just draw point A. We've got point A here. Walks 2 kilometers due north. So let's draw a mini compass on our screen. So we'll say that's north. Never eat soggy Weet-Bix. So that is going to be east, south. I don't know why I wrote south there. That would be west. So walking 2 kilometers due north. So we're going to go north by 2 kilometers. So there we go, 2 to a point B. So we'll call this point B. Now the person has walked 5 kilometers due west. So we're going 5 kilometers west. Now remember, all of these are right angles, right? South and west are exactly 90 degrees apart. So we can say that this is a 90-degree angle. So we're walking 5 kilometers west and we end up at a point C. So this is 5. So the question's asking, what is the distance between A and C? So what they want us to find is this distance here, the green. And that's going to be our hypotenuse. So let's just call that x. So once again, we're going to write the Pythagorean statement. X squared is equal to, first short side is going to be 2. So 2 squared plus 5 squared. That means x squared is equal to 2 squared is 4, 5 squared is 25. So that means x squared is equal to 29. And then to make x the subject, we just square root 29, put that into your calculator. And what do we get? We get 5.385. Now we have to read the question carefully. They only want it to 2 decimal places. So yes, you found it to 3, but they only want it to 2. So that means x is equal to 5.39 kilometers. Okay, so that would be our final answer. And finally, we come to our last worded problem of this video. A right-angled isosceles triangle has a hypotenuse of length 6 centimeters. Find the lengths of the other 2 sides in centimeters correct to 2 decimal places. Now, this question's a bit tricky. There's a lot to unpack here, so it might be a good idea to draw a nice diagram. So we have a right-angled, so that's an important word, isosceles triangle. Now, remember, isosceles means that 2 of the sides of the triangle are equal. So a right-angled isosceles triangle will look like this. So these 2 sides have to be equal. Obviously, the hypotenuse can't be equal with the other sides because, well, the hypotenuse by definition is going to be the longest side. So that means these 2 guys are going to be the same. We know that the hypotenuse is 6 centimeters, so we know that. And we need to find what the other 2 lengths are. So we don't know what they are, so we let them be x and x. Notice how I didn't let them be x and another letter because I know they are the same. So the same letter would be sufficient for both sides. So now we just write our Pythagorean statement. The hypotenuse is 6, so we say 6 squared is equal to the first side squared, so that's x squared, plus the second short side squared, which is x squared. So 6 squared is 36. That's going to be x squared plus x squared. We can collect the like terms here. So x squared plus x squared is 2x squared, and that's equal to 36. To make x squared the subject, we're going to divide both sides by 2. So 36 over 2. That means x squared is going to equal 18. And now to find x, we just put that into our calculator by square rooting 18. And the square root of 18 is equal to 4.2426. They want our answer to 2 decimal places. So we would say that the final answer is 4.24 centimeters. So our next video will be talking about Pythagorean triads. So make sure to check it out and we'll see you there.